Hello and welcome to lecture 14th of the course on corrosion, environmental degradation and surface engineering. I am going to cover this is the second lecture on environmental assisted surface degradation. We know that lecture 13 was also on this topic, environmentally assisted surface deterioration or degradation. Now, this whole course is basically on a surface degradation causing because of corrosion or other environmental assisted devices or mechanisms or factors, and finally, we will be giving some sort of remedies or mitigation strategies to minimize surface deterioration. So, this lecture 14 is also related to that, and then what we studied in our earlier lectures also, the degradation of surface is significantly influenced by environmental conditions. When I am using the word significantly influencing this kind of degradation, many times we do not know really all the factors, or we say that there are enormous number of environmental factors. Which factor will dominate in which situation may not be known completely unless there is a failure and we studied in a more detail and come up with some sort of guidelines. So, today's whole lecture is based on that, whatever were unknown earlier, and because of that there was some sort of surface degradation and how it has been implemented, maybe say what kind of regulation have changed because of that. Now, we know very well that the temperature or heat is one of the influencing parameter. Electromagnetic radiation like UV is also affect the performance or it causes a surface degradation. We have observed some sort of polymers and swelling of the polymers. We have studied also chemicals. Basically, there are many chemicals which really affect the surface degradation. We have studied something on the water or rain containing the contaminated water also. And then particles, maybe the soot particles, maybe sand particles, maybe dust, it will really affect the surface degradation. Now, what is really happening and then what is to be done? What has been mentioned earlier that because of the corrosion or because of the atmospheric corrosion, factor of safety will reduce. So, if I made a one structure and even the kept a factor of safety 2, then if there is I have not accounted corrosion factor, quite possible in maybe after few years or maybe say few hundred hours, the FOS will turn out to be lesser than 1, or the effective strength will come down and the structure will fail. That is why we say the corrosion can reduce FOS for the structure, increasing its likelihood that surface or maybe structure will fail, and that too in a brittle manner maybe suddenly. Even the ductile material, even like steel or iron may change their behavior, their fatigue behavior. They become like instead of the ductile material, they become a brittle material and sudden failure occurs. And it is in our history, we have many such incidents which have happened, and then because of that the science has further taken corrective actions to correct those things. Now, let us take example of the one incident which happened in April 28, 1988. What we say that there was some sort of airline, Aloha Airlines, flight number was a 243 flight number. It was basically a Boeing 737 and then the aircraft, and there was some sort of explosive decompression, and suddenly one door came out of the plane, and then because of that there was a one sort of casualty, and then when it was realized the plane landed safely without further damage to the plane, but one casualty happened. And whenever there is a casualty or human health or related to, we have to be little more careful whatever we design. We need to choose every parameter in a way so that no casualty should happen, no health hazard should happen. These are the example, like we were using very good materials earlier from a structural point of view, from performance point of view, but when we understood those are very bad for the human health, we stop that. Let us take an example of arsenic, or take an example of some sort of sulfur compounds. Those having a very good the characteristic, maybe heat resistance or maybe lubrication properties, but we change material over the time when we realize those materials are harmful for the human being, and then we need to change. So, this is what I have taken directly from one of the reference. If you go through this reference, they have given a number of case studies related to the aeroplane or aircraft, and then what kind of the problems happen, and then how the technologies have evolved over the period of time. So, this is what incident which has taught how to really go ahead, even though there was a one door which came out, and then it was basically corrosion assisted damage as such. So, even though what we say that maybe fatigue limit initially was for x hours, and because of the corrosion it has reduced to 0.6x or 0.7x or something like that. And another thing which we also have realized many times, the pipe components, even we know the drinking water comes from the pipes, and many times these pipes are made of the steel or maybe the iron or maybe some compound of that. In this case, we many times we find the debris in the water, or maybe say the contamination in the water because of the corrosion byproducts, which are harmful to the health, and then naturally those pipes need to be changed immediately, and that has been observed a number of times. Now, it is instead of water, it can be industry liquid also. Naturally, industry liquid, if it is really an industry fluid, if it is really getting contaminated, properties will change, and we may get some quite a different results. That is why we need to really take care of corrosion, atmospheric corrosion, or maybe say environmental factors which are really causing a deterioration of the surface, and finally failure of the system, or failure of the component, or failure of elements. Another important thing which we have also covered in previous lecture, that we need to really look at always what is the correlation and how corrosion and wear really integrated or interact with each other. Of course, in one of the lecture I mentioned the corrosion, wear and the fracture, how they interact with each other, whether really they are increasing, we say that the damage, enhancing damage significantly, and that is why we say that interplay between corrosion and wear play plays a significant role in assaulting many industrial machineries. We can name a number, but one of the very common thing which I have observed my own is a slurry pump, where the number of particles are there, and the pump's erosion happens, and because of pump's erosion, the new sites and new material comes out will be subjected to corrosion, further it will deteriorate with faster pace. Similarly, mining equipment, there are again a lot of erosion possibilities, surface getting exposure, and then when the presence of water. So, corrosion, wear and erosion will be a continuous phenomena on that. So, these are the very important and then the factors which when we choose a material, we design products, or we want to define the material and the component life, or we say that we want to enhance the reliability, we want to increase the serviceability of the equipment. Now, I will in my previous lecture also I covered something on a satellite, and that satellite particularly which is more useful in a low earth orbit environment, and we also mentioned in a low earth environment there is some sort of atomic oxygen which really enhance the damage, or maybe say corrosive assisted damage or erosion plus atomic oxygen reaction, it increases the overall damage. And in my previous lecture I mentioned 18% in one case and 13% in another case. However, there is also possibility the UV will act against along with other components, a charged particle, and even the meteoroid or micro meteoroid can impact on the surface of the satellite and damage. We also mentioned something like a rocket which is getting launched into the space, and then there will be some sort of debris, and which will be also having a negative effect on the satellite surface. So, this was to some extent explained in previous lecture, and then we say that and then particularly the low earth orbit satellite collide with the atomic oxygen at a high speed, and we mentioned that the speed has to be very high to maintain in orbit, otherwise it will be falling back on earth. So, the speed needs to be maintained, and that speed is significantly high. and then when there is a significantly high speed and the collision happens, naturally erosion will occur. Even in this case, we are talking about the collision energy roughly like a 4 to 5 electron volt, something like that. We generally talk about milli electron volt, but in this case we are talking about the electronic volt. So, this is important, is bigger than the possibility or more possibility of erosion whatever the material which we are using. In previous lecture we studied 2 coatings, and we say the one coating will be better than other coating in that phase. But now this coating material is also continuously evolving, and many researchers are working on that. So, I am just going to give a reference of one of the paper where they try to model the degradation of satellite, and then they consider the various factors. They consider the solar radiation, they consider the infrared radiation coming from earth, solar radiation reflected by earth, and then whatever the emitted radiation. So, they made a complete equation, solve the equation, and then they try to figure out what will be happening to different kind of coating or what kind of structures can be made, which will be a slightly better, will provide a better results compared to the existing coatings or existing materials in that case. Now, coming to the atomic oxygen, which was covered in previous lecture also, we say that in the low earth orbit environment, if the distance or the altitude from earth surface is 200 to 700 kilometers, then there is a lot of atomic oxygen already available. So, reaction will be much faster, impact will be much higher compared to the orbit which is beyond 700 kilometer. We mentioned yesterday that this the LEO is from 200 to 2000 kilometer. So, remaining 1300 kilometer atomic oxygen will not be available in abundant form, but if there is a molecular oxygen is available there in that environment, and if it is reacting with the UV light, then naturally there will be some sort of a photosynthesis work, and then it will create a AO also. So, if there is a molecular oxygen available there, there is a possibility of AO, but more of AO will be available in the range of 200 to 700 kilometer from the earth surface. So, these are the important aspects to consider, and what is really the altitude of spacecraft, or maybe say the satellite, and then if the satellite is within below 700 kilometer, naturally impact will be more, or maybe the effect of AO will be more. If it is beyond that, then naturally we need to look at what is really the level of the molecular oxygen, and whether a photosynthesis will occur, and what kind of how much AO will be then the release from that, and that will be created from that, and then that will impact the satellites. So, these are the important aspect, and then fortunately that this reference paper which was published in 2016 covered few features of that, and I am trying to elaborate that work only. It will really provide some sort of insight to us also, how do we really start thinking that implementing atmospheric oxygen effect, or maybe say atmospheric the corrosion effect in real materials. So, that what they did, they worked on a basically thermal control coatings. They wanted to say that to regulate complete control system of the thermal, or maybe the temperature regulation system, they need a coating, and then they use a 2 coating, what is called a white paint. White paint is a conventional been used in the various systems, and the name has been given as 781, and there was another new coating something like F46, and they use a word as second surface mirror. It basically the mirror system using the silver was created, so the reflection happens, so that we say the harmful radiation can be reflected back without really impinging or attacking to the thermal coating. So, this is what they try to keep research on that, and then we say that the thermal control coatings are crucial to keep the satellite in LEO at the safe operating temperature. It should not cause a damage to the satellite in this case. And then if it is not happening, then what will happen, the other environmental factor like even mention about AO will impact the space the spacecraft surface, or we say satellite surface, and it will cause a degradation and failure of the coating, and the whole system may fail also. Another thing which they have observed, whatever the best coating we are trying to do, but it will get the reduced performance over the time. So, that is nothing, not a single coating will be foolproof. Here today you are applying and it will last for the years. So, time dependence will come one way or another way. So, that is why I said they mention the coating quality and associate performance. What are the performance? Associate performance, they use the word a low solar absorption, the reduction in absorption of the solar system, solar rays, and then the strong infrared emittance. So, if there is a possibility of keeping absorption low, then is a good performance. If there is a possibility of emittance more higher value or stronger value, then performance is good. If both the performance are deteriorated with the time, naturally that we need to look at what will be the overall span of this coating and how many days or how many months it can last, and then we need to design according to that. So, this is what they have done, and then of course, they use a one coating something like as I mentioned a white pen 781, another coating something like F46, SSM is already been shown as a second surface mirror. Now, in a first coating which is a conventional, and then we use in that case particularly zinc oxide is used as a kind of pigments, and then in this case basically the zinc oxide has been selected because it is chemically stable as well as non-toxic and affordable, means the cost is not very high. So, it is affordable, however, in particularly in a spacecraft we may not work on affordability. We say that we require a more consistent performance, we do not really look at the low cost, because if the failure happens it will cause a phenomenal cost. So, to some extent affordability may not be really required for that purpose. However, if there is strong competition, then affordability or cost may be considered. Now, in this case particularly zinc oxide was used and then particularly that was also in a kind of binder, or we use the word organic binder. What is the organic binder? It contains silicon rubber, silicon resin and epoxy resin, and then it is a kind of a very thin coating which need to be placed on a solidized surface. When thin coating needs to be placed on a surface, naturally we require much more good quality control, and that is why they have used this kind of organic binder on that. So that the zinc oxide can be really attached or maybe act to prevent the radiation, to avoid minimize the radiation which is coming, and then to keep the satellite surface safer on the safer side. So, this is what was done in a zinc oxide related. Then coming to the F46 SSM, in the situation they use the FEP, which is a fluorinated ethylene propylene material, which is also kind of attachment used to the surface. And then in this situation they use silver backing, as I mentioned second surface mirror, to reflect the solar radiation and allowing only the solar energy to pass through. So, energy is required, but we want a harmful radiation should be removed or maybe reflected back, that has been done. Now, in between also they have used a silicon oxide as a the binder coating, so that it gets attached to the surface, and then the silver gets attached completely with to the surface, and then it should be minimum to minimum kind of air gap, or maybe almost zero air gap. However, they kept another one ITO, that is the indium tin oxide. Indium tin oxide and the conductive layer was capped on the outside surface to prevent again their thickness. If you look at the thickness is only 100 nanometer, and previous lecture we have mentioned around 10 nanometer, they kept around 100 nanometer to protect this layer against the erosion by AO. That is what we considered earlier. Now, in this case they have used ITO as a different kind of coating, and overall study what they have done, they found that this new kind of coating or composite coating is really performing well, and the multi-layer coating is performing well compared to single layer coating. In this case we find that there is a kind of a single coating, while in this case they have find that 3 coatings has been utilized on the surface. So, this the F46 SSM is been considered the better coating compared to the zinc oxide coating, but again it is not we can't say that this is the best. There is quite possible there is a more scope to perform a research on this area. However, it is indicating that when we go for the multi-layer coating and the kind of the functional coating, or each layer has its own function, it may give a better performance, it may give the better results. However, it may be the little costlier compared to the single coating, but we will cover this topic and when we discuss about the coating lecture. Now, we'll take few important failures which happen in our history, and then we analyze, and then how do we account those things in this case. These are the important for us. Let us take a famous failure of Titanic, and of course, everybody, maybe many people have seen already movie on this, and then there are various theories. People say many things about that. We say that this is a kind of the history, and then people thought science has overcome most of the hurdles, but that created a more problem, and that is what we are trying to cover in this maybe say next 3 slides, my way of thinking about the Titanic failure in this case. And of course, I am taking a reference from this in the publication 2022 publication, which they have mentioned about sinking of RMS Titanic, and they have given some sort of view. Is kind of a thermal inversion. What is the thermal inversion, and refraction mechanism or phenomena, what are those things we will try to cover in this 2-3 slides. We say that the Titanic failure happened somewhere in April 14, 1912, yes, way back, it is 110 years back, something like that. And what was a really major problem? We know that the ship struck against an iceberg. Iceberg was a kind of a solid mass or a cold mass, and the big unit, if we know that even that the ship has struck to that and the iceberg got damaged, maybe number of pieces, but it has harmed also the ship significantly. Now, another point which has come, that it has sunk also much more faster compared to the expected. Any time the breakage happens, it will take some time to really sink. It is not immediately. That means something went wrong, or maybe whatever the contingency measures, or maybe say whatever the fail-safe and the safe measures were required could not be done, and that is why the several deaths happened because of that. So, in this paper they have given a figure of sunk Titanic, and then they have given a kind of iceberg. They found that there is a possibility it is struck against this iceberg, and then location where exactly it happened, wreckage of Titanic happened, that has been location has been given, and Labrador current is the kind of cold current, and the Gulf Stream current, which is a high temperature current. They found that the cold water and high temperature water, when they mix, this kind of phenomenon, there is a possibility, and often people use the word optical illusion will be there. That means something which we are seeing may not be correct, and then we have seen this kind of situation, particularly when you drive a car on a road, and then they find that some water is available, or maybe in coal tar based, and then the road there is some sort of water appearance, but may not be water. It is basically a refraction phenomena, upward refraction, and that is giving a wrong illusion that there is a possibility of water. And similarly, in a desert also, many people feel there is a water, maybe say few meter away, but when they reach, they do not find that kind of thing. So, what we call as a mirage or optical illusions, or maybe many names can be given to that. So, this is what they have mentioned. Now, they try to give explanation what is the thermal inversion. We say it is a meteorological phenomena, and basically is the trapping of a layer of a warm air near the earth's surface by a layer of the colder surface. So, there is something like the temperature differences, cool air than high temperature air than cool air. Otherwise, what will happen in natural, we know that as the temperature increases, air will move up, and then move up, it will reduce the temperature, and temperature will be dropped. Well, in this case, it does not happen in this case. We say that is why I say the normal air becomes colder as the altitude increases. Now, if there is some sort of high temperature layer above the cold temperature, then it will give us some sort of illusion, because cold air will not be able to skip, and then we may feel little more cold, maybe change in the weather, something like that. So, and then this is what was mentioned as a kind of a thermal inversion. We say that when the warm air near the surface is unable to rise and mix with the cold cooler air above during thermal inversion, this layer operates like a lid. So, that means there is a kind of the thermal cap on the surface. It is basically providing some sort of insulation, and then cold air gets trapped in a cold and that environment, it does not move out, or maybe if there is a hot air, it will remain hot air, it will not be able to move out. So, this is a kind of that it is really not happening the way our nature works, but there is a such opposite things are happening in this case. And then because of this incident, they mentioned that the iceberg visibility was difficult. That is why if you look at many literature, when they find that the captain was not able to see the kind of iceberg which was there already, and then that was the reason being the refractive phenomena, or maybe say that superior in the mirage or inferior mirage. Another one, whatever that they have a lookout, so they have a camera, they could not really find out what is the real distance. Maybe the real distance was something like a few meters, and then they were observing like a few hundred meters. So, that means that they were thinking there is enough gap and we can really take a measures on the defensive measures, but they could not take the measures, reason being that immediately the rally struck happened, or maybe the collision happened, and then there was not a the planning, or maybe the overall planning was missing for this kind of a casualty. And then what we are talking about the 1912, that's 110 years back, and then now after that science has improved significantly and it has increased shown the better results. So, if I want to express in my language this complete thing, we say thermal inversions are widespread in particularly winter seasons, and then the cold air remains in the lower side, and there will be some sort of the pollution layer or contaminated layer which will be making somewhat the kind of cap on the surface above the cold air in our case, and this creates a kind of trap fog, or which is that this kind of trap fog will also reduce the visibility. And then if it is what will happen, we have also experienced that it will create a lot of transportation problem. In real life, if there suddenly fog comes and then we need to reduce the speed, because and then the weight, what is the direction, because visibility will reduce significantly. Of course, now many cars and many vehicles, they have a better visibility and the units that even the fog case, even there is some sort of unnatural the phenomena which is happening in nature, and visibility is not clear, but because of the we have good cameras, now we will be able to improve the visibility using those devices. And what we say that basically in this case, in this way we talk about the inversion, is really the keeping some sort of there is a cap. So, we can assume there is a kind of the formation of cloud, and this cloud also can prevent our dirt, or maybe say whatever the exhaust gases moving away from environment. So, it will give a kind of unhealthy environment. So, this kind of thermal inversion should be minimized for whatever reason. Now, if it is happening naturally, now we need to understand and then we need to take a care to minimize that one. Now, question comes also why we are discussing this topic in our course, reason being that as I say that thermal inversion in my view is a major effect, is going to create a problem for the air quality. And in this lecture we are saying if the air quality is bad, or it has a more like a chemicals which can enhance the thermal the atmospheric corrosion, that should be minimized. And another thing that there is a trap and there is some sort of cloud which is really giving artificial layer on us, and then this contaminants, they are not able to escape the environment. Naturally, it will really affect the our products, whatever we have made, it will affect also human health. So, it is important to understand that. So, I can say the sluggish condition and restricted mixing of air during the inversion which happened, that because cold air does not get escaped from the environment, and then because there is the layer on the top of the contaminated layer, it will really give a kind of because its mixing is not happening. So, it will really give a kind of smoke and poor air quality. and then we have also realized in the winter season particularly the quality of air drops or maybe the goes on worse side, and then now we need to take many measures and particularly water spraying and all to reduce this kind of the contamination. So, from technical point of view, I can say that Titanic was failed because of there were a number of material related problem and design defects also. Even in this case, I say that whatever the rudder they used, that was too small to control the ship. And again another thing, whatever they thought the watertight compartment they have made, but that was not sufficient to prevent the flooding of the compartment. That we found that there is a flooding of the compartment also happened. Another thing which they used that time, it was a much lower grade steel. Now we have better steels and to be utilized, and because they use a low grade steel, that is why the hull got fractured bitterly compared to the what we can think about the life of the hull in these days. And then another thing is that because it fractured immediately by the collision, it did not deflect. If it would have deflected, we could have taken maybe at that time captain could have taken some other measures, but it immediately failed, and then there was not sufficient time. Another thing which report says there were some sort of rivet heads, and then they got completely removed or maybe broken off, and then even the hull assembly becomes weak there. So, there are many parameters, many technical difficulties, or many we say that there are many design and manufacturing and corrosion related problem related to Titanic. But question comes, a major question comes, that happens, everything happened after striking with the iceberg. And quite possible the scientists who were working on that, or maybe the researcher who were working or who made this kind of ship, they may not have thought that this kind of collision will happen with the iceberg. So, if now in these days we design something, we need to really think from all odd situation. That is why we are considering this case study. We need to really think all odd situation, particularly when we are handling this kind of atmospheric situation, and then the human traveling, or maybe say we are transporting through that vehicle from one place to other place, that because the health hazards or maybe say human life are very important, we need to really take care of all. Now, there is another one website which I found in this case. This is the Fox Weather website. They have given a complete impact, or they shown how really things have happened. So, this is what we say, why did Titanic strike iceberg? Now, from a researcher point of view, from designer point of view, say it was never ever thought that there is a big iceberg and people will not be able to see this iceberg and there will be striking against it. There is a huge mass, and it's something like wrestling is happening between the two units. It is not possible to think from a designer point of view. But now, what is really happening because of atmosphere, that has been shown there. So, they have expressed that the Labrador current, with which I have mentioned in previous slide, is basically large surface current in which is the North Atlantic Ocean. This current comes from Atlantic Oceans. It carries really cold water from Arctic Ocean to Grand Bank region. That is how all the regions are being connected, has been shown in previous slide, and then it passes through the western side of Labrador Sea. Now, what they mention clearly, that there is a very cold water, what we call the fridge water, is something like almost icy form of the water, and then there is a warm water. So, there is a huge temperature difference between the two water streams. When it happens, then naturally thermal inversion process will occur. What is the thermal inversion process, what we are saying? What will happen, what captain could see a false horizon. What is a false horizon means? He could see something like this much only iceberg, when in reality there was a much bigger iceberg, and which was not possible to see because of we did not have a very good cameras that time. So, actual horizon was maybe say the level of this iceberg was very high, then the height difference was very high. Maybe whatever they could see something like this height, and in reality there was almost 2 to 3 times the height of that the huge mass. Now, if we want to see in slightly different manner, now you can see here that there is a ship, and this is the iceberg. Then the iceberg dimensions are huge. Now, what will happen if this ship goes and strike against this or this iceberg? Naturally, big collision will occur. So, one is a collision and second is a speed. They are capped at 22 knot speed, very high speed. Whenever we get this kind of warning, at least we could reduce the speed, or whenever we are traveling driving the car, we immediately reduce the speed. Maybe we are driving the 40 kilometer, 50 kilometer, we find suddenly visibility is diminishing and we are not able to see much. Then we come down to maybe a few kilometers only, maybe almost over 10% of that. However, captain kept a speed around 22 knots and design speed was only 23 knots. The maximum speed could be achieved using this kind of ship was 23 knots. Captain was driving at the 22 speed. So, huge mass and huge speed also, the maximum speed. Naturally, everything will happen immediately, instantaneously. Now, whatever you take a defensive measure may not be sufficient, it can save few people, not many people, and that is what has been shown here, big collision between iceberg and a ship, that is what has been mentioned over here. So, basically optical illusion which has happened because of thermal inversion, and then the height of the unit was different, and then even the captain was confident about the kind of technology which that was developed that time. Yeah, my ship will be able to overcome this small iceberg which is hardly any dimension as such. So, there is a possibility that he overcome, he assumed that it will this difficulty will be overcome. Now, one of the paper gives everything in detail. Whatever I mentioned, they say that this is what the camera, the position, what they were able to see is like a straight line, but in reality what will happen because of the change in the temperature, variation in the temperature, even whatever we are looking at the straight may not be correct, and then that is why they say that they found this a green line of sight, and then they found there is no maybe say some sort of a portion of the iceberg only, which was a negligible small unit and can be damaged also with the big ship moving in this side. However, an actual horizon was somewhat different, and then the reason being there was a banding of the site, and then the false impression came, and then they tried to show this also that this is the iceberg, and then because of the false in this unit they had below the line, while in this case either this tip was visible or there was no tip at all. They could not see anything, even though there were number of warning, and that is what the experiment says. There were at least 6 warnings were issued at that time from neighboring places that there is an iceberg, but captain was not able to see iceberg. So, something like he could not understand whether it is really for warning for him or maybe somebody else. So, this is what has been shown here, and the authors have tried to show the kind of looming horizon from a Titan, and then the vision was maybe when camera they found there was no iceberg as such, and then they use also green dotted, yellow dotted, that is what I have been shown. This was a green, I have made kind of a violet color, now this is a yellow color, and then they found as a false horizon. They were not able to see the surface of iceberg, and then they struck directly against the concealed iceberg, and this has been caused because of the thermal inversion, and then what we say the refractive index, or maybe the refraction because of that. So, in this case and then this, now if I see this is a natural phenomena, and captain and then could not see the iceberg, and that is why everything happened, everything looks to the natural. Now, other things if I look at in a totality, I find there about the human error which is there, or another faulty construction, because number of design features when we look at and we find there are mistakes, maybe and we are now able to find those mistakes, maybe that time they could not figure out, that is why that. So, human error, faulty construction, and as well as environmental condition all contributed to the damage of the, or maybe the rapid or the faster damage of the Titanic ship. So, you say that Now, what is why I am using the word human error? Reason being, when there was a warning, at least the ship could have been slowed down or reduced, the impact would have been much lesser. Because there is already warning, and there is at least 6 warnings were issued, and then ship could have been and then the damage could have been reduced to that. So, whenever there is some sort of big collision and we need to take really energy into account, if there is a collision, there is a v square, the sensitivity of velocity is very high, and there is a big mass also which is going to strike against the surface, that need to be accounted very clearly. Now, another point comes that whenever this phenomena happen, there was no direction completely how evacuation should happen. So, we can say that evacuation was also poorly organized, and that is why the many death happened really. And this is basically learning. We are not trying to blame anybody, but we say that we should take these measures importantly, I mean in a better manner, that whenever the possibility of the situation may arise, we need to really document everything properly. If this happened, what should be done? That is what and moreover another thing is that as I say, there were a number of boats available, but as we know that human tendency that I should be saved first, not others kind of thing. So, that is why even the boats which were there, but they could not take all the people, reason being that there was some sort of what is a lack of clarity what is really happening, and few people have a lot of emotion for the ship. So, they wanted to be there, not taking and getting away from the surface. So, there was a lot of confusion, there was no clear directions. So, many problem happen. It is not only the technical, maybe human errors were also there, environmental, but this compounded effect that is becomes a history, and it's a well documented the thing also. But however, we are trying to cover in this lecture, we say that atmospheric corrosion or atmospheric casualties will really cause a major problem, and so we need to account whenever we design, we want to really minimize the surface damage of anything, we need to account many points. Now, another which that I found, particularly that when a ship hulls, there is we keep in a mind that if there is this kind of damage happens, it should be divided in many sections, and the reason being the surface area will increase, and then there is a possibility of floating, and then however they found that those also were not watertight. When the surface area is there, but water gets leaked into that, naturally it will sink also. So, that is what they found that there were some sort of difficulties, some sort of drawbacks in the design, and then this bulk unit itself was were not safe. And another thing is that and they use only one, like in these days we mostly use 2 engines, or we use some sort of extra and particularly when there is chances of atmospheric and the damage possibilities are there. So, they use only the single hull, while in these days the regulation has come after that, particularly that even that there should be a double hull, so that it should be protected, the ship should be protected in all the situations. And another one, as I mentioned, that particularly when you travel in these days the aircraft, they use give all the safety norms at the beginning itself. So, reason being that whenever this kind of atmospheric casualty are happening, it is not only the what you say that the thinking that people should be saved, it should be the everybody's responsibility. So, that is why the people should be really provided sufficient knowledge that what kind of safety measures should be taken if this kind of casualty happens. So, if you may have traveled through by air, you know that at the beginning of 5 minutes or 3 minutes they give completely measures. Of course, many times we overlook and we say what this is rubbish, we do not have to worry about that, but this is an important thing. The safety drills must be mentioned, almost everybody should know, should understand this kind of incidents are possible. It should not happen, but these are the possible, and then also we need to really be prepared if this happens, how to really control that situation. Otherwise, there will be chaos and there will be more deaths, and then we do not want that. So, this is what we say. Another one is that there was a radio station, and somewhat because of the anxiety or whatever reason, they could not use a radio transmission also effectively. So, this is another problem related to this. So, this case study particularly really gives a many insight that how do we really, when we design a product or when we think about to minimize the damage, how to really consider the different kind of atmospheric conditions, and then how to really think in each and every way and then possible document, so that and then we can provide, we can take all the safety measures appropriately. Now this is what we have mentioned about the Titanic, but there is a similar kind of incident what we are talking about 1912. Now similar kind of incident happened in 1999 also. That's of course human involvement was not much there, but whatever happened after that, society got really and this is the hamper because of that. So maybe say for years and years. What happened into the December 12, 1999, there was a sinking of Erika ship. Erika ship is basically was carrying the oil, particularly versus the heavy fuel oil, and the capacity was something like 31,000 metric ton, and then it was carrying something like a 20,000 metric ton on the time, and then incident happened. This whole oil got spilled into the water or the sea water because of the ship was divided in two parts, major failure. Now if you look at this case study, maybe that this already is available on this website. Now what happened in that situation, they say that basically corrosion was the main culprit of the complete failure, and corrosion, whenever we talk corrosion is a main failure, we know it has to be associated with some sort of maintenance. Corrosion will not give a failure in a day, it will give us sufficient warnings. Only thing, because we are involved in some activities, we do not consider that much. So this is a regular phenomena, we do not have to worry, something like that. But in reality, corrosion gives sufficient time, it does not cause immediate failure, it gives a number of things. Maybe whatever we have perceived, we say 5 years, maybe it gives a 2 years, maybe it gives a 2 months, but it does not happen instantaneously. Another point comes like we take a ship from one place to other place and it has moved safely, but after that again we start, there is a possibility failure will occur, because this is a continuously progressive failure. It is not going to be stagnant, it will not be the kind of only one crack, maybe say 1 mm will remain 1 mm, maybe quite possible 1% growth will be there. And naturally we need to know what is the sensitivity, at which time it will fail. If you are able to simulate that properly, then we should really drive this kind of unit, or we use this kind of units. If we do not have a knowledge, we do not have a science, better we should not use this kind of corrosive products. So that is what has been mentioned. And the corrosion lead to a structural breakdown, and as I say, the ship was splitted in two parts, and the whole oil leaked to the sea water. And then when the oil is leaked to the sea water, naturally the life in a sea water will not be good enough, and there will be kind of casualty, not on the human, but kind of the fish, or maybe animals, or maybe the complete units there, that there will be more and more problems. And now after that, once this kind of failure happened, now they have a stronger norms. As I say that and then after Titanic, there were the new norms came to the ship design. Similarly, after this there was another new norm related to what kind of age should be the maximum age upper limit, and then after that we need to discard, it cannot be used that way. Now here we are mentioning here, Erika was already 25-year-old ship. It has sustained already 25 years life, and enough warnings were given from 1994. That means after the completing 20 years of life, enough failures were indicated that this ship will fail because of this, ship will fail because of that, this safety measure is missing, this safety measure is missing, but somehow it continued, whatever reason for that. So in this case, in the age, another one, that now almost all this kind of cargo vehicles, maybe the ships, they need to use a double hull double hull tanker design. It cannot be single hull design being to the safety measures. And then in this case, now if you need to follow international maritime laws, otherwise she will not be able to move from one place to another place. These details are already given on this website, as I mentioned. Now, as I mentioned that enough warnings were given to the to the concerned company that these are the corrosion issues in a Erika ship and should be corrected, but maybe they could not maybe they did not really paid much attention. And as we say, we many times we say this is a normal thing and it will sustain for some more life, and many times we feel, oh, I have an experience, it will survive for 3 years, I have experience for 5 years. But now in new science we need to really prove everything, we need to do a simulation, only feeling may not work. And then if we need to really document everything, it will be good for the science, it will be good for the future also. The new and new generation will be able to learn better and better, they will be able to develop better and better product. If I think only from my experience point of view it will work, does not make much sense, because we need to really list down why I am feeling, we need to document properly, and if that is a really the right thing, at least a new generation will learn that. Now, another thing which was also mentioned in particularly in the report was that even the firefighting systems were not in a position. If there is a fire incident, the ship is carrying 20,000 ton of the oil, if there is a fire, what kind of safety measures will be there? So, again it will cause a more problem naturally. And another thing what was mentioned that the time to time whereas society have given a report related to corrosion, and finally it came that even the certificate out of maybe say it ran out in March 1999, but this incident happened in December 99 after 9 months. So, they were going without any certificate kind of insurance. So, that is another thing. So, we really need to see whatever that there is a possibility, we should account everything. And in my view, there was no attention paid to the maintenance, what kind of maintenance strategy need to follow, and then if they would have followed the maintenance strategy properly, this kind of failure would not happen, and maybe it was because it has caused a huge problem on not only the area, but economy also. Now, we know very well that tourists will not go to this location, they know something will be happening to their health. So, naturally overall economy will come down, the people who are living there, what is their fault? Because of our the lack of maintenance strategy, or maybe because of lack of science, we are going ahead, naturally there will be more problem, and then we need to take care maybe when think from a science point of view, from learning point of view. Now, I will just take a couple of more case study. Now, let us take example of a steel bridge. Now, you must have seen a number of steel bridges, and then you must have seen this kind of discoloration, pitting, and some sort of corrosion, and again same thing the way Erika ship, as I mentioned, similar kind of the stresses you can find out misalignment and maybe separation in a number of bridges. Now, this is a kind of initiation of the failure. When the system is designed initially, many times it will comes up perfect, but over the period even one nut and bolt gets loosened, then there is a shift in the load, stress concentration will change. When whatever initially we thought were equally distributed on 10 bolts, maybe one bolt got loosened, and then we say that unfastened, remaining 9 bolts will get more load. Now, second bolt got unfastened, then naturally it will get. So, this will be kind of misalignment, there will be kind of separation, and that is what is a major problem related to the steel bridges, because there are many joints, many joints. So, I find either we should remove all the joints, but again in that situation the construction will be very costly. So, if we want to really keep a cost and then the construction cost minimum, we need to have a joint. But if there are a joint, and we need to think about, even like I have seen many people and then they go with the welding operation, they do not learn how the welding should be done, they learn only through the experience of the skill development, and they do not know how to make the face appropriately, how to align the face appropriately, and then at what points really need to be welded. But this is really happening in many places, and the bridges are getting fabricated by the people who are not very skilled, and then initially maybe say 3 years, 5 years we find the bridges are very good, performing well. but after that the deterioration happens, and sometimes the bridges are closed and maybe routine maintenance is done, that is good. Otherwise, there is a one kind of the collapse will occur or the failures will occur. Now, this is we have taken this from a 2015 reference, and then they say the effect of the corrosion and cracks, particularly they have covered some steel bridges, which are on the failure of the steel bridges which have happened really. And if you ask me in my view, I say that these are the basically material fatigue and corrosion. These are the two phenomena which happen grossly in this kind of failures, and particularly steel the bridges. Now, why this kind of problems are coming? I find many times there is an imperfection. Assembly, as I say, that there are many units getting assembled. So, if assembly is not a proper, if imperfections are there. Now, if I take a factor of safety 1.5, 1.10, maybe say 6 or maybe say 2 or 2.5. So, some sort of assembly which say that stress level I am able to account, but this is a dynamic process. Today factor of safety 2.5, maybe after 5 years it factor of safety will turn out to be like a 1.2. Maybe after 10 years maybe 1, and after that failure will occur. So, this is a dynamic process. Whatever we have done initially, that is a static design, but dynamic, that every time situation will change, and that is why we say many times we need to look at the real time maintenance. We predict something, but we need to really see what is really happening and what kind of measures should be done immediately. So, most of the times this failure are happening because of inadequate maintenance. So, we need to work on the maintenance strategy, particularly for the heavy structures, particularly where the traffic is there. And then another point, that many times the population continuously increase. If I have designed some bridge for 5,000 people walking over that bridge every day, quite possible that the increase in a population, this 5,000 becomes a 6,000, 6,000 becomes a 7,000, or maybe we have designed some sort of maybe say 1,000 ton load kind of thing, where maybe the load will be maximum 1,000 ton, but possibility that more and more vehicles are coming, it is increasing the load, and maybe sometimes there is a traffic jam and many vehicles are simultaneously there. So, those are the dynamic situation we need to account and then design, and then maximum permissible. Otherwise, we need to come up with the maintenance strategies, what kind of maintenance strategies should be done, so that even whatever initial design which I have mentioned, static design, should also remain effective throughout its length. It's maybe maintenance strategies should take care of dynamic design or maybe aspects related to dynamic design. Now, what we are saying here, that because of the imperfection in assembly, that will create a stress hotspot. There is a misalignment, naturally some portion will be bearing more load compared to other portions, and that is basically where the crack initiation start and crack propagates. And if there is a crack, which we already studied earlier in a previous lecture, that increase in a crack causes a fracture. And then I also mentioned about atmospheric corrosion, many times because of the water, because of the crevices that remain because of assembly, that gives a good spot for the electrochemical cell to be formed and is increase the stress level or maybe the corrosion level also. So, this is what we say, atmospheric corrosion over the time weakens the stability of the steel bridges, should be considered. If the corrosion is not maintained, it is not addressed appropriately with a maintenance strategy, that means where there is a corrosion, we remove it and then we make a necessary measures to minimize the corrosion expansion, that then if friction, finally the failure of the bridge will occur. Another thing is that even the bridges will have some foundation, and that also need to be considered. We know that when the bridges have a foundation and there will be soil, there will be water, and there is a possibility of the misalignment load that will also cause a failure. So, we say that basically corrosion and material fatigue are the major problems, and then we need to, if we want to really go ahead with a longer life, the bridge should remain for the many years, then we need to have a frequent the inspection and maintenance of that unit. So, these are the important aspects. Now, as a given the reference, they have cited a few examples, like in this case they have given a front view and this is the front view and a side view of a one bridge. You are able to see the failures of the bridge here, and then there is a complete failure over here. Now, there is another one and the failure has been shown, and last one there is a mid span of the complete bridge has been removed because of whatever reason, the failure of the bridge. So, these are basically structural deficiencies. The paper indicate there is a structural deficiency, and the reference of the paper has been given here 2009, and these are the deficiencies in bridge in the structure. That is why the failure has occurred. Now, what is really highlights of this is that basically there will be a localized buckling. If there is a misalignment, load will increase one way, another way, and there is some sort of a cantilever, maybe say over stress condition. In that situation, there will be possibility of the localized buckling. Now, what are the parameters? Sometimes the width to thickness ratio is been not kept constant, or maybe then kept in a proper way. So, insufficient width to thickness ratio, sometime incorrect insolation, as I say, the load will increase, there will be misalignment. As I say, loosening of the fastener is one of the major issue, or maybe if there is a rivet, then corrosion or fretting of the rivets will be a major issue. And then because of that, this kind of problems, there will be more stresses at the certain unit compared to other stress. There will be kind of unequal distribution of the stresses. So, few components are going to be over stressed, and then naturally stress level will continuously increase, and if there is a presence of corrosion, the strength will come down. So, stress is continuously increasing, strength is continuously decreasing, naturally factor of safety will continuously come down, and the failure will be a result. So, this is what with the steel lectures, but as I mentioned, the steel bridge connections become weak and vulnerable as a result of atmospheric corrosion or air corrosion, which is a more prominent prominently at the joints, welds, or wherever the connections are built. Those are the weak points. If you know very well that when the material strength is high, but if I make a weld connection, the strength will need to be counted on only 60 or maybe 67 to 70% of that, because that is the weakest point. Naturally, when we are connecting two units, even though we design with the completely fastening unit, but if there is some sort of loosening, naturally strength will come down significantly. So, basically they are, I can say, the inadequately built connections. And then another, whenever there is a inadequately built connection, what will happen, even the mode of the fatigue will change. Whatever I thought the fatigue will happen in this manner, no, may not be. It will shift, the mode will shift from the one mode to other side, other condition, and then the overall lifetime of the fatigue, whichever we estimated, will come down. So, that is why we say the fatigue lifetime of the components will be shortened in these situations. And as far as my knowledge is concerned, in this case basically poor welding gives us sites to make a corrosion seal, and that corrosion really weakens the unit completely. And so, I can blame finally insufficient fabrication. Maybe design is perfect, but fabrication is not correct, or fabrication methods are not correct. As I mentioned, the welding itself, the welding which has been done may not be correct. So, that will not be realized instantaneously, it will come after time. So, that is the performance is deteriorating with the time. So, static design is good, but dynamic design is going towards the side. As I mentioned, the strength will come down, the stress will increase, factor of safety will continuously come down, and that will cause a major failure. So, this is what we say, that insufficient fabrication method reduce the fatigue bridge structure under atmospheric corrosion condition, and eventually it will result in a degradation of structure. So, integrity of the bridge members will come down and leading to the catastrophic failures. So, this is one of the, as I mentioned, the steel bridge. Now, let us take one more important aspect, particularly we are saying that atmospheric assisted surface degradation of aircraft. You know, the cloud, we like the cloud, but cloud itself has so many particles, and then it has a water also, and when aircraft pass through that cloud, speed is huge. So, whatever we were thinking earlier for iceberg and the ship, aircraft finds similar kind of situation, but of course, the mass is much lesser, speed is much higher almost every time. So, naturally the coating or maybe surface protection in this kind of units needs to be much better, and that is what has been done. Maybe the years and years they have developed a good product. Now, in this we have taken the reference of the 2011, we say that the impact of erosion particularly aircraft that has been mentioned over here. Now, if you look at these are the dots and there is a some sort of the hatch portion, there are small dots and there is a bigger dots. So, they have shown kind of erosion possibilities on a surface of the aircraft. What are the possibility? So, these are the possibility, and wherever the black dots are there, small or bigger, those are the possibilities of erosion of the aircraft surface. And then we are saying there are bigger dots, so there is a larger dots correspond to the medium speed. The medium speed of the particle which is getting impinged on a surface. Again I am using the medium speed of the particle, does not mean the particle may be stationary, but vehicle is moving at a high speed. So, we need to look at only the relative speed, we do not have to look at the absolute speed. Even the bird is flying and then suddenly aircraft strike, then the collision will occur, it will cause a major damage. Even the bird may not have a lot of mass compared to the mass of the aircraft. So, that is what we say, the larger dot basically medium speed, smaller dot means kind of a lower speed, and hash region as I mentioned over here, this is giving high speed. So, major failure will occur at the front end only, right. Others are also shown the failure. However, wherever the pit formation occurs and it becomes a source of corrosion, then we need to really look at. That is why the aircrafts are generally maintained very carefully. It is not that once you make aircraft after 1 year we will look into that, no, it is not. They have been really observed continuously. So, that is what another thing. Another, as I mentioned, the birds and insect, whenever the birds or insect strike against the aircraft, they use the word FOD, something like a foreign object damage. It has caused foreign object damage and the bird strikes against the surface of the aircraft, they use this kind of terminology. So, that is also we need to be accounted. Now, coming to the air atmosphere, we say the airborne pollutants, there are many. It can be rain, as I mentioned, it kind of ice, maybe say small particles, and then maybe sand, maybe ash, maybe various dust particles, and then they will cause a short term physical damage. So, when the bird comes and strike the surface, a particle comes and strike the surface, there will be some sort of deformation, there will be some sort of impingement of maybe there will be some sort of depression, but that is what we call a short term physical damage. Long term damage happens because of the corrosion, because that is giving kind of pocket cell for water to get ingress and then start activity. So, that is the initiation happens because of the initial impact, and that is why they wanted then this reference they wanted to distinguish erosion and impact. Something of the impingement, they say there is a kind of impact, it is not really removing the material. Erosion is basically a removal of material, we say the erosive wear, it is a removal of the material, while impingement is a striking. Now, because of a striking there is a possibility of the material getting removed, then it will be cause of erosion. So, they say that we want to use both the words impingement as well as erosion. Now, we have studied in erosive wear, actually angle of attack will depend, if the angle of attack is smaller, naturally there will be more like cutting wear. If angle of attack is a higher side, maybe 80 degree, 90 degree, there will be failure of the vertical. So, that is what we have when we were discussing of erosion, is it can be classified in two categories, one is the abrasive wear, other one is the fatigue wear. While in this case we are saying impingement is a one, it may not cause erosion, it may not cause a material removal, but it causes some sort of pit formation, some sort of deformation, and that is what we call the short term physical degradation or damage. While corrosion, because there will be water, will be, as I say, the water particles will be available, it will cause a long term corrosion damage. So, this happens to the surface of the aircraft. Now, what is really more dangerous? Say more damage is basically is the hailstone impacts, the bigger particle that comes and strike on the surface, which will cause a serious harm, reason being a bigger dent, not a smaller one, is a bigger dent. Now, it can also remove the material from a surface, so the surface abrasion also is possible, and then even the whole structure, not a localized structure, gets completely deformed also, there is a possibility. Now, while these are the more harmful, while sand, ash and other airborne dust also have a kind of high hardness As one of our lecture mentioned, the sand has a very high hardness, even much higher than the steel surface. Naturally, that will cause abrasion, that is a possibility. So, that is why we say the erosion of aircraft outer surface may occur whenever this kind of atmospheric and the particles are coming and impinging and is causing atmospheric assisted surface degradation of the aircraft. And this is the impact. Many times they remove also the protective coating or maybe the paint which has been used for protection purpose, and then it will further cause a risk of the corrosion. Atmospheric corrosion will be dominating and will overall reduce the life in this case. Now, and then we say the creation of the sample pit, and then particularly the whatever the indent they happen or impingement happens, and presence of the rainwater. Now, by using the one rainwater, if there is a rainwater, then naturally if there whatever the gas is, it will also get dissolved in the water also. So, it will have a dissolve. It is not like a mineral water kind of thing. So, this may contain the gases, it may contain other contaminants also. So, it will be a very kind of providing ideal environment for electrochemical reaction or enhancement of the corrosion. So, these are the possibilities and surface degradation will happen. Now, I am just trying to show the two figures, particularly and the people have learned because of the failures of this. Is a one is a kind of and then the aircraft has been shown here, Sabre aircraft, and particularly oval air intake has been shown, and then they found the radome was damaged, particularly after the rain. This is the radome is a kind of front portion of the aircraft, and this incident happened in 1959, and then this aircraft damaged not a very high altitude, is only 5,000 feet, and then the speed was reasonably high, that the speed was somewhere Mach number 0.76. So, in this case and then after this failures, particularly they found this kind of erosion is happening on the front portion of the aircraft, but the radome of the aircraft, naturally we need to change design, and then to mitigate, that is why they to mitigate this kind of risk, they change the design, even operation procedure, and then what kind of maintenance strategy should be done. So, they give a lot of emphasis on that design within the maintenance and what kind of operation should be done if they find some sort of failures. So, particularly aircraft, they find very good maintenance, and then they go with a regular maintenance also. Now, coming to this one has been taken also from 2011. In this case, they particularly they use a new, they wanted to improve the aircraft design, and they thought about the phantom aircraft design in this case, and then they have presented results in 1973, particularly erosion test were done on the phantom aircraft, and then they wanted to modify the design of the profile of the aircraft, and that has been shown over here. Here the altitude was kept lesser than 5,000 feet, but the Mach number was increased, the Mach number was 0.99, and at very high speed, and then they found damage almost everywhere, and then they found the radome damage, paintwork damage, pitted particularly speed measurement probes damage also. So, after this they say if they are going to really go ahead with a very good design of high speed vehicle, which is in these days demand, that if the speed of the vehicles can be increased significantly, that will be more useful, because overall it will save the time for the so many people also. So, the lot of efforts are given to increase to go for the better and better design, but if this kind of failure occur, naturally aircraft cannot be flying at that high speed. So, that is what they have given many suggestions to improve that kind of surface. Now, let us coming to the last case study, but we say that degradation of the buildings. Many monuments are there in India and abroad also, and many monuments have been listed in a UNESCO World Heritage List also. So, there is a need to think about that, and top of that, are these monuments one way or another way related to human health also, because let us think about some metals have been banned in India, but you find those metals are there when you go for the monuments, and on the surface of those monuments what will happen, and this is what are these monuments are working as a store for those elements. Let us take an example of the brake shoes. We say the brake shoes composition was changed. Now, old brake particles which have flown, maybe flown from from vehicle to the some sort of monuments, and because if there is a no regular maintenance of those monuments, the particles will go and reside on those. So, now from commonplace we are not getting health issues, but when we are visiting those monuments, we are touching those monuments, then maybe the particles are also coming within our hands or fingers, and we are taking along with that. So, that will cause health issues. So, these are the important aspects when we think in totality. So, that is why this paper has been referred. This is published in 2021, and they have they studied the two architectures or of the France, and then they have been shown various portions, and then they found everywhere contamination. Almost every portion has a contamination, and then they took some sort of EDX also, they have analyzed those also. So, I will be presenting in 2 slides on this. So, in this case, as I mentioned that 2 France historical building were taken, which were been listed in a UNESCO World Heritage List, and many tourists want to really see this kind of buildings. Now, what is the really aim of this study? They say primary goal is to learn the consequences of air pollution, because we are talking about atmospheric pollution, atmospheric assistant to cause a damage. That is what they have studied, and that is why I am referring in this case. We say that these are the air pollution is basically human activities. The driving is one of the human activity, automobiles, and then public transportation, and sometimes manufacturing, and even the agriculture farming, whether that will cause any failure or kind of contamination, or maybe it will whether enhance particulated matter, and will there be a deposition of on the building surfaces, and then if there is, then will they be providing kind of electrochemical cell formation. That is what I mentioned, that if there is some sort of formation of electrochemical cell, naturally corrosion will continuously increase, and the building may collapse also, will get discolored also, and then we need to really think about those monuments which are listed particularly for tourists. And then if we are not able to maintain those portions because of some reason, and again in this case the materials have been utilized. In some cases you find certainly aluminum material, maybe is around 200 years back, and that time aluminum was not extensively used, or maybe some sort of a titanium, and that was not extensively used. Actually those things have come from other sources. Now, it has come from other sources and residing on a surface of the monument, naturally it needs to be cleaned, and then we need to really think what is really happening. Whatever the science gives a sort of understanding to us, we need to implement that. So, in this case particularly what they mentioned, and then they concluded the procedure for the routine maintenance must be there, because they found many places the black crust, and the black crust means maybe lack of oxygen, lack of the sunlight also. Now, if there is some sort of contamination on the top, and maybe it is not allowing the sun and the sun rays to reach to the surface, actually it will cause more and more cumulative damage. So, it should be removed as soon as they find. So, that means the regular maintenance is important of this kind of monuments. And as I mentioned that in addition to diminishing the structure aesthetic value, black crust can continually degrade the surface. So, one is the aesthetic aspect. People look at the better and better surfaces, or maybe real monuments. They should not look at the layered or mask monument. Other thing is that also the degradation should be reduced. If we do not take care, go ahead with the proper maintenance, the degradation will occur. Now, I am just showing the detailed views. Now, this image has been taken on the 1 micron scale, and what they found is spherical particles, and they found also the nanoparticles in this case. And then they mentioned very clearly that many buildings have been mentioned, and then because of the poor air quality, because of the porous structure, and then these materials come from outside, and spherical kind of materials, they are not abrading, but coming and residing on the on the buildings. And then these particles also contain some sort of nanoparticles, and that too agglomerated nanoparticles. We know very well that nanoparticles have a lot of attraction for other particles, and agglomeration happens immediately if you do not take care properly. So, that these are the agglomerated nanoparticles, and then it may contain, again they are using the word, they contain the risky substance. They found some sort of arsenic, they found a lead, they found the cadmium, chromium. These are all the toxic materials, and then should not be available in our environment. Maybe it was banned, those materials were banned maybe few years back, and these materials are still there on the buildings, on building surface. Naturally, that will cause some sort of, these are toxic materials, they will cause some sort of health issues. So, that is why it is an important thing. And another thing, they have found ultra fine particles, particularly nanoparticles, even create some sort of health issues to us also, and then they remain in the close to the structure pores, whatever that there are pores. And another thing is that these pores do not really absorb completely, they remain there, but it can be easily removed also. That means, if you do a regular maintenance, can be cleaned and properly maintained. If you do not, that it may be getting transferred with other people who are visiting, and it will unnecessarily cause more and more problems, right. So, to preserve the building, it is crucial to address hazardous materials. Particularly, we are not talking all the materials, but few materials are hazardous, and those should be cleaned, and then particularly if there are the nano level particles, we should not enter in our breathing system or through nose, but because when we go close to those buildings, there is a possibility that we inhale those particles also, or maybe we touch the buildings, or maybe we want to see really the texture of the surface of those monuments, and finally we inhale those particles also. So, in my view, those are kind of a storehouse, whatever the particles or whatever materials have been, quite possible that this monuments become a storehouse. So, you are not seeing this particle come to my building, I will be able to provide you those particles, something like a storehouse for them. So, this is a very important, and then that is why I say that if particles are there, and actually there will be possibility, and then already health hazards are there, and if we do not clean it, there is a possibility that neighborhood resident also will be subject to this kind of danger toxin, because air will be there, particle and the toxic material which remains here, it can be really transferred through air to other places, and then if there are neighborhood, and then they can really find this kind of hazardous for them also. So, this is important, and that is why I say that even these nanoparticles or the spherical particles, they remain, they have observed, these are all the outside particles. When the buildings were made, this kind of particles were not there, but if these are the toxic materials, again using the word, not all particles are toxic, but it may contain toxic particles, that is what they have mentioned. Now, they have also shown what are the element structures using the EDX, or they use the word EDS, energy dispersive X-ray spectrography, spectroscopy, and in these days we use a kind of XRD kind of thing also. So, they have used this kind of thing to understand what kind of particles are they are creating. So, what I can think what they have observed, they have said that the EDX results shows the aluminum, silicon, calcium, potassium, sodium, chromium, iron, antimony, molybdenum, and all other kind of elements they found in those on those surfaces. These particles, when combined with the soil or maybe the settled dust from the building material, but probably these particles, what they think they came from brake shoes, or maybe say even the tracks, particularly the train tracks, and this alarms two things. One is that the particles have come from because of the railway track or maybe the bricks, and particle have released from those materials, those systems, and be airborne and finally settle to those buildings. That is one possibility. But if that is really happening, then when we are traveling through the train, or when we are really traveling on the road, what happens? The brake shoes are going to really give a number of particles, and whenever there is a strike, or maybe say particles will keep coming, and we have found also whenever you go for the maintenance of car, the brake shoes need to be changed, because already brake shoes have worn out. That means we really require some sort of design where the breakthrough life can be extended significantly. There should not be any breakage, and if these particles are kind of a nanoparticles, are very very small particles, and if they are easily intact by the human, naturally it will go inside a human body, and naturally it will really cause many issues also. And particularly when we are not, this is if suppose the train related thing, if we are not frequent travelers in a train, but people who are operating train or like who are really maintaining the trains, naturally they will be exposed to this kind of the pollution, this kind of contamination. So this kind of science really helps us to understand that system failure should not be happening, building failure should not happen, as well as the health hazard should not happen. If we are able to take care, naturally we will be able to really achieve better and better scientific society, science, we say the society by science also. So thank you.